Welcome everyone. I'm Alison from the Postgrad Association. Here we are today at our final session of 4 with Dr. Megan Lee, Advanced Statistics and SPSS. So I really want to actually thank you, Megan, for a big thank you really for giving our students your time and expertise to, really get their research projects, moving ahead. So I'll put a few links in the chat box about recording and becoming a member. Otherwise, it's over to you, Megan. Thanks so much.
Thank you, Alison. And I would like to start by giving the SCPA a big shout out. I always explain at the beginning of each workshop that I graduated from my PhD in June of 22. And my PhD journey was not the smoothest of sailing. I had some rough patches. And if it wasn't for the Southern Cross Postgraduate Association and the support that I received from them, I don't think that I would have ever finished my PhD. So there was a little bit of politics, a little bit of stuff happening in the background with the actual university itself, things like that. And because Southern Cross Postgraduate Association aren't actually an association tied to the university, they can advocate for students and help in so many different ways. I also found so much support in the networks that all the people that I met during the Praxis conference. 8 of the students who I met through the Praxis conference are now still part of my best friend circle. We catch up all the time. We used to do PhD writing retreats at the back of Byron Bay, and we range from 20 to 70. So it's 8 of us girls, all doctors now. And so just the networks that I made through the SCPA was just amazing. So please, if you haven't already, join the SCPA. It's, just such a great support for people. So we'll move on because I always get flowery about the SCPA. So I'm Dr. Megan Lee. I work at Bond University now, but I am an alumni of Southern Cross University. I have a PhD in nutritional psychiatry, so I have expertise in everything to do with diet and mental health. I also am a body image researcher, particularly in populations of postpartum women. So around that pregnancy, post-pregnancy stage. And I do a little bit of work. It's kind of a bit of a passion project for me on the impact of student feedback surveys on academics' mental health. And I do a little bit of that work with Daniel, who's also here today. So if you're interested in my research or want to see my trajectory from honours all the way through to now, you can follow me on the socials. I do lots of fun food stuff on there as well. Or if you have any questions about research, statistics, or anything like that from the workshops today, feel free to email me at any time. I'm happy to help with any questions that you have. Please do keep in mind, though, that if you do want advanced statistical tutoring or anything like that, there is a fee for my service if I have to come in and actually go into the data and help you with that. Because sometimes people get the wrong idea with that. But you can organize that through the SCPA as well. All the recordings for the workshops are online, the SCPA YouTube, or also you can find them on my website as well, foodmooddoctor.org. So today, things are a little bit more advanced than what we have gone through in the past 3 workshops. So the first workshop that we have done was beginners statistics and SPSS, where we stepped through from the very, very foundations of taking the data out of your survey software, putting it into SPSS, what all the tabs in SPSS mean, how to clean your data in SPSS before you are able to analyze. The second workshop was intermediate statistics and SPSS, where we moved into looking at participant characteristics and descriptive statistics. So averages and the most common scores, things like that, standard deviations. So the preparation statistics that you need to do before you start trying to analyze to answer your research questions. And then the last two workshops last week and this week were your more advanced statistical analysis to answer your research questions. So if you have been to the other 3 workshops, you'll be in a very good space to understand what is happening today. But it is that more advanced understanding. So you'll probably need to have at least a foundational understanding of regression to understand kind of what is happening today. So if you haven't, feel free to stay and learn by osmosis, or you can go back, rewatch the workshops from the beginning to now, or even just the last one on multiple hierarchical regression before you rewatch the recording for today. Because we do get quite in depth with some of the more advanced terminologies, and it is better to have that basic understanding of how regression and the general linear model works. So today we are going to start the workshop by looking at the elements or the frameworks of how we write up statistical analysis. And luckily for us, there's a system and a process, and it's always the same. So I'm going to teach you the similarities of writing up from your participant characteristics all the way through to your analyses, from the more simple analyses that we've done in the past couple of workshops. Then we're going to move on to logistic regression, which answers research questions when your dependent variable or your outcome variable is dichotomized. So it is split into 2 categories. All of the other analyses that we've done up to this point have been when your outcome variable has been continuous. So on a scale from -infinity through to 0 up to +infinity. So on like a ruler. Today is a little bit different. Then we're going to move on to ANOVA. So analysis of variance is when you would like to look at the differences between the averages of groups, but you have more than 2 groups. So 2 groups is your t-test. So kind of looking at the differences between an intervention group and a control group, or someone say depressive symptoms pre and post test, they're all your t-tests. But ANOVAs start looking at what happens if I have more than 2 groups that I want to see the differences between. And today we'll be working on categorizing our plant-based diet population from the Vegetarian for Life dietary data set that we've been using up until now, and splitting them into vegan, vegetarian, semi-vegetarian, pescatarian, flexitarian, ovo-vegetarian. So we're going to look at all, I think it's 5 or 6 different groups and the differences in their depressive symptoms and whether there were differences between those groups or not. Then I'm going to step away from SPSS for a moment and introduce you to a free online software program called JASP, which you don't have to upload onto your computer. It's web-based, and it can do all of the things that I've taught you in SPSS and has a very similar interface to SPSS, but it does streamline mediation and moderation. Now, mediation and moderation are 2 extra analyses that you can do on top of regression that we'll look at today. But in SPSS, you have to download a whole extra add-in, and it's really super complex and clunky. So I'm going to show you a little bit of JASP today and how to do mediation and moderation in JASP. So before we get going, are there any questions that you have for me about today, or any comments about anything? I know some of you have been to the other workshops, so okay, perfect. Well, we will continue then. So for the last 3 workshops, we have been working consistently with the same data set. So this is a data set that I collected last year in March. It's the Vegetarian for Life and Depression data set. And just to give you a bit of an idea about how slow the research process is, this paper is still under review. We've just received reviewer comments and are revising the paper. So it's it's 13 months later after data collection, and we still are not published. So that gives you a little bit of an idea, and that's a very common time frame for these types of things. So just to let you know, that's how it works. So we will be working inside that data set. So it is completely live. There was 470 something participants. After data cleaning, we ended up with 319. Sorry. 30% of the participants in the data set were from India, 30% were from Australia, and 30% from other parts of the world. So that's important to know for today about our the cultural aspect of this data set. But we are going to get right into it. So before we do anything, I think it's very important to have a chat about the reporting requirements when you are writing up statistical analysis. So back in week 2, we looked at descriptive statistics of the data set, basically telling us what our participants looked like. We looked at gender, we looked at the type of diet, so whether the participants were vegan or vegetarian, keeping in mind that all of the participants in this data set have been vegan or vegetarian for their entire life, from childhood all the way through. So, and the reason that we did this is because in our other cross-sectional surveys, we had this idea that we didn't know how long our participants had been plant-based for, how long they would stay plant-based for, and how closely they were actually adhering to their plant-based diet. Because when we did the food frequency questionnaires, many of them were indicating that they consumed meat. So that was very interesting. But in this data set, that is not the case. So it removes that limitation of, are we really looking at vegan and vegetarians, or are we actually looking at low meat versus high meat consumers? So when reporting our participant characteristics, we usually always have a table of the characteristics, as you can see here on the right-hand side. Now, when reporting in text, you don't want to report all of the information or repeat all the information in the table. You just want to pull out the most important parts of that. So we usually describe and always introduce our table. So that's one of the important things, is we definitely want to report as seen in table 1, and then we talk about the important factors. So for this data set, one of the most important factors is the fact that we have vegans and vegetarians. So how many do we have and what percentage? So we had about 49% vegetarians and 51% vegans, which was really great because they were even. The groups were even. We wanted to keep them as even as possible. And I kind of made sure that this was happening when recruitment was happening. So if we ended up with, say, 80% vegetarians and 20% vegans at one point in time in the data recruitment, I could check Qualtrics and then start doing more tailored recruitment towards vegetarians, towards vegans, to bring that number back up. So that's why they're quite even, because I controlled that during recruitment. So we also want to describe the gender balance. So we had 62% female and 36% males. That's really important. The mean age, sometimes people also like to say what the age range is, but you can see from this that the mean age was 39.63. This is quite an older cohort compared to what you would normally see, particularly in psychology research, because a lot of psychology research, because of convenience sampling, is on university age students. This was not the case for our data set. So this is quite important finding in itself, is that 40-year age range. And the standard deviation kind of tells us that there was quite a large range of ages. So 60% of the data set fell within the ages of, say, 23 to 53, basically. Now, another important thing was geographical location for this study. So we had 30% of our participants in India, 30% in Australia, and the rest from other countries. So this was really important. And part of the reason we're having trouble with our review at the moment, because they don't like the fact that the cultures are so different in both depression and in diet. So that's something that we're working on at the moment. And the fact that 83% of our participants had a university degree. So that's a really important finding to put in your participant characteristics, but we don't go and list. There was 15% in high school, 83% in university, and 2% in trade. Just that the important part of that is that we are predominantly a university educated cohort. And this is developing a picture for your reader about what your participants look like. So it's really, really important. Now, the outcome variable depression, it's important to describe what the kind of average score for that was and whether or not it fell above or below the clinical criterion cutoff of 16. So this data set, the participants on average scored at 14.27 in depressive symptoms, which was underneath the cutoff, indicating a population not experiencing clinically significant symptoms of depression, although they were sub-threshold. So they were kind of on that threshold anyway at 14. So that's another important finding. So taking all of those things that we found in our descriptive statistics and bringing them down to what is the most important thing that the reader needs to know to build a picture of your participants. And then later on in your limitations section, you can revert to these and say, yeah, do you know what? 62% female cohort, very highly educated. So maybe we're not getting the results of, say, lower socioeconomic status participants, or the male voices might be a little bit muted in this. So always thinking about those things as well as the fact that the cohort isn't really experiencing the symptoms of depression also is an interesting thing to put into your limitations section in relation to the findings later on. Now, in week 2, we also did a t-test looking at the differences between the vegan and vegetarian groups and their depressive symptoms and all the other characteristics. And what we found was very interesting. So between the two groups, there was no difference in depressive symptoms. There was no difference in social connectedness. There was no difference in BMI. There was no difference in diet quality. And there was no difference in sleep quality. So at the end of our participant characteristics, we can write that. So a t-test was performed to explore the differences between the two groups with all the variables, and no significant group differences were found. And that's all you need. Even though we did, say, 7 or 8 t-tests, we found no significant differences, which means that as we move forward with our analysis, the reader knows that there are no big differences between those who are vegan and those who are vegetarian, and that the results that we found aren't contributed to a big, say, depressive symptom difference in, say, the vegan group. So we're very much aligned. So then we also, in week 2, looked at the correlations or the relationships between our variables. And here you'll see a correlation matrix. This is always the second table that we report in any paper where we use linear regression or anything to do with relationships, because we cannot conduct regression analysis, logistic regression analysis, mediation analysis, unless our variables are significant with each other. So if the depressive symptom variable and the diet quality variable are not significantly related, then we can't predict the relationship, and we can't see if there is a mediator in that relationship, because it doesn't exist. So correlations is the next most important step. And we always report our correlation matrix, which tells us which of our variables have a significant relationship with depression. And you will see there the CESD, or the Center of Epidemiological Studies for Depression scale column, is always first. So our outcome variable is always first, so that we can just read down that first column for the relationship between all the other variables. So you'll see here DST, which is diet quality, has a negative 0.27 relationship with depressive symptoms, which is a medium relationship, and it is significant. So the stars on the correlation matrix indicate, as you can see from the note down the bottom, the significance. So 2 stars is significant at the 0.001 level, and 1 star is significant at the 0.05 level. Any relationship in the table that does not have a star is a non-significant relationship. And this is a really easy way for your readers to see these relationships without you having to write all of those relationships into text. So we do a little bit of a text blurb of the most important relationships, which will be the relationship between our predictor and our outcome, and some of the other ones, mainly the co-varying factors that we're interested in from the literature. So if we know that, say, BMI has a relationship with depression, we know that sunlight exposure and education level have a significant relationship, we will report them. But we only need to report the ones that are significant in the table. We don't report any of the ones that are non-significant. So table 2, again, always introducing the table in the text. There is a significant negative relationship between depressive symptoms and diet quality. Report the R and the p-value. Social connectedness, which is the SCS that you can see there. Report the R and the p-value. Marital status is also significant. Education level, geographical location, sunlight exposure. They're all of our negative relationships. So as those variables go up, depression goes down. And then there are positive relationships between depression and poor sleep quality, depression and anxiety, and depression and stress, which you would assume would be a high relationship. So we just want to report the significant relationships in our correlation. And then if you were to be doing a regression analysis, a logistic regression analysis, or a mediation after this, you would then go on to say these significant relationships will be built into the regression models, as we did last week. Then if you move on to regression, as we did last week, this is how you report your regression. You will always have your regression table, including your standardized beta, your t-value, which tells you what in the model is significant, and then how much variability is in your model with your R squared, and then your SR squared. And then in your report of your regression, you always describe how you built your model and then what you found in your model. So a 3-step regression, hierarchical multiple regression, conducted to explore the association between diet quality and depressive symptoms after controlling for demographics and lifestyle covariates. So you always start with your first sentence describing what the analysis was and what you were analyzing. And this is the same for t-tests, ANOVAs, regression, all of your data analysis that you will be doing today and in the future. You always report with the first sentence what the analysis was, what you were measuring. Then you move on to what the model looks like. So in step 1, we included diet quality. In step 2, we put all the demographic variables in. And in step 3, we included our lifestyle factors. Now, for those of you who were here last week, you will know that we did our regression, and the way that I recommended doing regression was demographic variables first, your least important variables in the model first, then your lifestyle factors, so your co-varying factors second in a model together, and then diet quality by itself in the third model. And what we found was that the demographic variables had about 5% variability in depression. So they took up about 5% of depression. When we added the lifestyle factors, they took up about 52% of the variability in depression. And then when we added diet quality didn't add any more variability. So it was not significant. So in that case, when your predictor becomes non-significant when it is added as the unique variable at the end, you need to flip your regression around and do diet quality first, which is what we've done here. So, and that is a completely fine thing to do. It's not harking or hypothesizing after the fact. It's just changing the model so that you can understand what is going on. You can also report in your report that you did it that way first, and then you flipped it to be completely transparent. Now, the reason for this is because in this model, you'll now see that when we added diet quality as the first variable, it now has 5% of the variability in depressive symptoms. So there is some diet quality is taking up some of the variability. So when we did it the other way around, it just looked like there was no relationship between, or there was no prediction between diet quality and depressive symptoms, but there actually is. So flipping the model around makes it more transparent that without controlling for any demographics or any lifestyle factors, there is a relationship. Then in step 2, we add the demographics and diet quality remains significant. But then when we add sleep quality, social connectedness, and sunlight exposure into the third model, diet quality then becomes non-significant. So that's telling us a much better story than doing it the other way around. So keeping that in mind when you are reporting regressions and things, if you do want to flip the model, it is completely understandable and allowable. But the interesting thing here is that either sleep quality, social connection, or sunlight exposure, one of those three are removing the prediction of diet quality from depression. So when something like that happens, that's really interesting because there is a prediction, but something is removing that, or something might be completely mediating that relationship. So then a mediation analysis is going to be important in this data set to find out which one of those or why that is happening. So we'll do that today. Any questions on reporting before we move on to our new analysis? Not so far. Everyone's with me? Nice. Good, good. And keep in mind, please, that these workshops are designed specifically, and the rest of this workshop in particular, so that you can rewatch the recording when you're actually doing your analysis, and you can stop me, you can pause me, you can rewind me, you can fast forward bits that you already know. So that's why I speak a little bit slowly so that you can do that. But it's basically done so that you can follow along when you do your analysis later on. So the new research questions that we have. Number 1, does diet quality predict depressive symptoms between clinical and non-clinical participants? Now, the reason for this research question is because back in our participant characteristics, when we had a look there, on average, our participants were underneath the clinical cutoff for depression. So what we're going to do is we're going to take the continuous variable of depression and split it so that those who are above the clinical cutoff of 16 and those who are below are in 2 separate groups. And we are going to do a regression when we've dichotomized our outcome variable. Thank you, Daniel. Yes, that's exactly why this is done this way. So, and feel free to do that for all of the workshops. Is there the second research question that we're interested in today? Is there a difference in depressive symptoms between different plant-based dietary groups? And you'll notice that there are bolded words in these research questions. These words will, if you ever see them in the scientific literature, or if you're in an assessment task or an exam and a lecturer asks you to predict something, predict is the word that's synonymous with regression. Relationship or association is synonymous with correlation analysis. Difference is synonymous with t-tests and ANOVA. So difference between 2 groups or difference between more than 2 groups. And then mediate, obviously, is your mediation, or moderate is your moderation analysis. So sometimes the clues are in the wording of the research question, and they should always feature in a research question if that's the analysis that you're using. So research.
I'm
yes?
sorry. Would you could you repeat that? I thought that was pretty valuable to know what each of the terms are going to relate to. So
Yeah.
you said that predicting is synonymous with regression.
Yep.
And then after that, what did you say with relationship?
Relationships and associations are synonymous with correlation analysis.
Okay.
Differences are synonymous with t-tests and ANOVA. So t-test for 2 groups and ANOVA for more than 2 groups.
Yep.
And then mediate is mediation, moderate is moderation.
Got it. Thank you so much.
Rianne's actually put a really good question into the chat. Is it common for new research questions to be made up halfway into research? Good question, Rianne. So usually your research questions should be made a priori. So that means before you collect your data. And they should be really pre-registered with Open Sciences Framework. You should always have a pre-registration document for every analysis that you do in quantitative analysis in Open Sciences Framework. When it comes to new research questions being made up halfway into the research, so I can see where this question is coming from, because from our participant characteristics, we've noticed that our participants are not really in the clinical category for depression. So what these research questions are called then are post hoc research questions, and they shouldn't feature kind of up in your intro lit review research aims hypotheses section. They should be included in the maybe methods section, where in your data analysis strategy, where you explain that you've done your regression. Then after the regression was conducted, it was noticed that the participants were not meeting the clinical cutoff criterion. Therefore, we did a logistic regression to look at this. So these are all post hoc analyses. And if you use the word post hoc analyses, then you won't get in trouble for hypothesizing after the question. Very good question. All right. The third research question is, does social connectedness mediate the relationship between diet quality and depressive symptoms? So again, this is another post hoc analysis, right? It's another post hoc question, because we've run our hierarchical regression and we've noticed that when we put social connection, sleep quality, and what was the other one? Sunlight exposure into the model, diet quality is no longer significant. So we want to see if one or all 3 of these are mediating the relationship between diet quality and depressive symptoms. So that's another post hoc analysis after the fact. So I actually did this because this is a live data set, and we did find that both social connectedness and sleep quality were mediating the relationship between diet quality and depressive symptoms. So that's a really massive finding, to be honest, especially considering in my PhD, I also found in like the qualitative focus group data that I did that social connection and social connectedness was the largest contributing factor to food and mood. So it's a thread across quant and qual. So it's very exciting. So post-hoc analysis can actually tell you a lot about your things, but they are surprising findings. So you can't expect them from the beginning. So let's look firstly at the first research question. Does diet quality depict depressive symptoms? Oops. When we dichotomize or categorize our participants into clinical and non-clinical groups. All right. So what we're going to do now is we're going to actually go to the data set in SPSS. I'm just trying to get. Okay. So I'm going to stop sharing my PowerPoint screen and I'm going to start sharing SPSS. So what we're going to do is we're going to look at logistic regression. We're going to do the logistic regression and then we will come back to the PowerPoint slide. So this is SPSS. So again, those of you who have done the workshops before will have seen this before. This is our data set with all of the participant characteristics that we just seen in the table. So gender, age, BMI, geographical location, marital status, vegan or vegetarian, whether you're vegan or vegetarian, a plant-based variable, which splits the participants into vegan, semi-vegan, vegetarian, semi-vegetarian, lovo, ovo, pescatarian, flexitarian. Keeping in mind that we allowed participants to self-report these to be sensitive because they don't want to just be categorized into vegan and vegetarian most of the time because there's such nuance in this dietary pattern. So we allow them to do that. But it also gave us the opportunity to have a look across all of these categories and see if there were differences. Sunlight exposure, we've got our depression score. So it's the Center of Epidemiological Studies for Depression Scale, so CESD for short. We've got our dietary screening tool, which is our diet quality score. So higher scores on this mean greater diet quality. We've got social connectedness score. So this one's a little bit different. It's around the opposite way, which kind of got me freaked out a little bit the first time I did it because all my relationships were the wrong way around. So the social connectedness scale, the higher the score, the less socially connected the person feels. So it's more lonely at the top of the scale. Sleep quality scale, so the SQS is the higher the score, the greater the sleep quality. And then we've got our depression, anxiety, and stress scale. And we've got the IPAC, which is physical activity. And then we've got height and weight, which we used to measure BMI. So we don't ask people what their BMI is. We measure it ourselves from height and weight. If you want to see how to do that, go and have a look at I think it was in workshop 1 or workshop 2 we did that. So that's a variable view. This is our data view. This is where all of our participant answers are to our questions. The participants are each row and the variable or the question that they answered is each column. There's 319 participants in total, as we saw in our participant characteristics. So up to this point, if we were to be answering this logistic regression question about predicting the differences of depressive symptoms between the vegan and vegetarian groups, between between the clinical and non-clinical groups, we would first have to dichotomize our depression total score, because our depression total score right now, if I show you here, is a continuous score. So each person has a score between 0 and 60, and it's continuous. So we have to figure out how to categorize this into clinical and non-clinical. Now, we know that the Center of Epidemiological Scale for Depression scores over 16 mean that you have clinical depressive symptoms, and under is not. So let's go and create that variable. So we will transform, recode into different variable. And the reason that we do this and we don't ever recode into the same variable is because if you recode into the same variable, it will override the continuous data column. So you always want to create a new variable. So recode into a different variable. We want to take the Center for Epidemiological Studies, or you can change the display variable names over. We want to create a new variable called the CESD cat, or categorical. The label is CESD scores dichotomized, something like that. Then you want to click change to change the variable name, and then click old and new values. Now, these values are in a range. So anyone who scores between a 0 and 15.99 on the CESD scale, we want to nominate them to be in category 1 as the new value. And we click add. And then anyone who scores from 16 through to 60, which is the highest score in the scale, we want to categorize them as a 2. We add, continue, and then OK. And all the way at the bottom of your variable view, a new variable will have been created, which categorizes the depression scores into clinical and non-clinical. So we want to drag that up the top here. I'll place it underneath the other CESD variable so it's in a good spot. And then we just want to clean our variable. So it's a numeric variable, that's correct. The width of the column, we want to keep it at 8. You'll see that all of them are at 8. Because it's a dichotomized variable, it doesn't need decimal places. So we click that to be 0. This is the variable, the label that you will find on any tables and figures. And then in the values box, we want to add that anyone who was a 1, we categorized as 1, was 0 to 15.99. So they were not experiencing depressive symptoms. And then we add the category of 2, which was 16 to 60. And these were participants who were categorized as experiencing depressive symptoms. So they're our categories that we label. I like to keep my columns at 8. So you'll see everything's all aligned there. I like to center align all my variables. You don't need to do that. It's just something I do. And then you just make sure that your measure is correct. The scale measurement is any continuous data that can fall on a ruler, and you can see the little ruler there. Ordinal data is categorical data that is in an order. And then nominal data is categorical data that's not in an order. So our nominal data is correct for this variable. Then we go back into the data view with the tab down the bottom, and we find our CESD categorical. And you'll see here that our variable is now labeled with depression or no depression. You can also right-click on the variable and sort ascending, and that will show you all of the no depression. And then right-click, sort descending, and that will show you all the highest values, so all of those who have depression. And it looks like here, out of the 319, only about 125 were actually experiencing clinical symptoms of depression. Now, the next step, that's the first step in logistic regression. You must always have a dichotomous or a categorical variable with two groups as your outcome. And then we just run a logistic regression. So we analyze, regression, binary logistic, because our outcome variable has two categories. If your outcome variable had more than two categories, like our plant-based dietary variable that we saw before, you would do a multinomial logistic regression. So it means more than two categories. But we only have two, so we're going to do binary, which means two, logistic regression. Can you see the pop-ups? That's, if anyone can tell me if they can see that pop-up there. You should be able to. It's just the output that makes that you can't see usually. Good, good, good. All right. So in our logistic regression box, we put our dependent variable, and always make sure that you put your categorical CESD score in there, the one that we created. And then our predictor variable. Who can tell me what the predictor variable might be for this question? So the research question was, I can't even remember now. I'll read it out to you. The research question was, does diet quality predict depressive symptoms between clinical and non-clinical participants? What do you think the predictor variable is? If the outcome variable is the depressive symptom scores, what's our predictor? Diet quality. Good, Rian. Yes, it is. It's diet quality. So we're trying to predict what someone's depressive symptoms would be from the quality of their diet. So if they eat a healthier diet, will we be able to predict if their depressive symptoms will be lower or not? So we find diet quality, which is this one here, and we put it into the covariate box. Then we click on save, and we want to look at some of our assumptions testing, and we talked about assumptions testing last week and in week 2. Assumptions are things that need to occur before we can do our analysis. At this stage, the logistic regression is really a post hoc analysis. So we've done our assumptions testing on this data already. So we've seen if the data is normal or normally distributed. We've looked at independence, so making sure that no two people did the survey more than once, no one influenced each other's answers. Linearity, so we've made sure that our outcome and our predictor variables, so depression and diet quality, you can put a straight line through a scatter plot. And we've done homogeneity of variance when we did t-tests, so that the two groups were, the variances of the two groups were similar. So those assumptions are really important. So this is an assumption test. So Cook's distance and standardized residuals will tell us if we have our assumptions are met. They should be, because they were last time in our hierarchical regression. Then we look at options. We want classification plots. Hosmer, Lemmy show goodness of fit. We want case-wise listing of residuals. So this will tell us if we have any outliers, and we want them to be any outliers that are above 3 standard deviations away from the mean. Correlation of estimates, iteration history, and we want to see our confidence intervals. Continue. And then there's our bootstrap button. Now, we talked about bootstrapping last time. Bootstrapping occurs if our assumptions have not been met. So if we don't have normal data, or the residuals in the regression are not normal, or we don't have a linear relationship, we can bootstrap. So you just click that button and you can bootstrap. If you would like to know a little bit more about bootstrapping, there are some really good videos on YouTube that explain the process of bootstrapping and how it works to mitigate the bias in that the assumptions or violating the assumptions creates. Okay, so that's our logistic regression. Let's run it. Okay. Now I need to stop sharing and reshare my output. So this is our logistic regression output. And it's a little different to what we're used to because it shows the relationships between diet and depression in 2 blocks, and we'll get to that. So the first box tells us how many participants we have or how many people are in our regression. So 319, that sounds right because that's how many participants we have. It then goes on to tell us that the codes that they used for the variable, the outcome variable, 0 means no depressive symptoms and 1 equals participants with depressive symptoms. Then block 0. Block 0 is the beginning block, and we are comparing the beginning block to the second block or block 1. Now, the beginning block is the regression run without diet quality. So it's like the perfect model. If all of the participants in the analysis were all on the mean or the average, then that would be block 0 with just depression in the model. So what we're trying to do is we're trying to find out what the first model is, and then if adding diet quality into the second block or into the second model increases or is a better model. So if it is a better model, that means that adding diet quality decreased depressive symptoms. And we'll go on to see that in a second once we dichotomized it. So the classification table tells us if we had the perfect model or the average was used and all of the participants had an average of depressive symptoms, that 194 participants would have no depressive symptoms and 125 participants would have depressive symptoms. Now, this is what we did see in the model. Remember when we looked down the column, we did see that 125 participants had depressive symptoms. So in this case, if we looked at depressive symptoms in this way, we would get the model correct 60% of the time. So that's important to remember. So 60.8. If in block 1, we have a higher percentage, that means adding diet quality to the model improves the model. So we want to remember that 60.8% there. We want block 1 to be higher than just what the average model would be. So variables in the equation. So this tells us, like if we think back to last week when we did hierarchical regression, this is the same as whether the model is significant. So the Wold test is the same as your t-test value. And the betas are the same as the betas in a hierarchical regression. So this tells us what in the model is significant. We can see here that the model is significant at p less than 0.001. And then we have our exponential b, which is our odds ratio. So that's all we need to know from our beginning model. Then we want to look at model 1. This is when we add diet quality to the model. So the first model was depression by itself. Now we add diet quality. Are we going to improve the model? If not, then diet quality doesn't add anything. So let's have a look. So going down to our chi-squared. So if you look back to hierarchical regression, the ANOVA box, which was really important, tells us whether the model is significant. And then the coefficients box tells us what in the model is significant. So the omnibus test of model coefficients here with the chi-square is the same as the ANOVA box. So whether the model is significant when we add diet quality. And we're looking at the step chi-squared 31.87. Significance is less than 0.001. So our model is significant. If the model wasn't significant, we would stop, pack everything up, and the sentence that we would write into our report would be, there was no significant difference in diet quality and depressive symptoms when the depression score was dichotomized, and you would just stop. But our model is significant, so there is a prediction. Now, our model summary, the Nagle-Kirk R-squared is similar to the R-squared in our multiple regression. So Nagle-Kirk R-squared of 0.129 basically tells us that 13% of the variability in depressive symptoms, clinically and non-clinically, is taken up by diet quality. And that also means that 70 or 87% is taken up by other things. So 13% is taken up by diet quality, which is cool. Then the Hosmer and Lemy-Show test is our homogeneity of variance test. So whether the variances between the clinical and non-clinical depressive symptom groups are equal or even or not too different. And because this is an assumptions test, we want it to be not significant, because we don't want there to be a significant differences in the variances. So our Hosmer-Lemy-Show test is not significant, which is perfect, which means that our assumption has been met. Then our classification table. This is the one that we're comparing to back here. So does anyone remember, without diet quality in the model, what percentage of the model were we getting correct? What do we remember? About 60%. Yes, it was 60.8%. And the percentage that we're getting correct when we add diet quality to the model is 69%. So it has increased by 8%. So that means the model is better with diet quality in it. And this also is backed by the fact that the chi-square is significant. So the model is significant. So then the variables in the equation box is similar to the coefficients box. So what in the model is significant? Our WOLD is the same as our t-test. So the dietary screening tool, it is significant with depressive symptoms in this case. Now, we could go and do what we did in the hierarchical regression, in the logistic regression, and add all of our covariant factors in block models exactly the same. And we would probably get a very similar result to what we got when we did that for the hierarchical regression, because dichotomizing the variable isn't really changing the variable, the value that much. So you would probably find that if we did the model the same, that diet quality would lose its significance once we put sleep quality, social connection, and sunlight exposure in. Good. So that is our logistic regression. So I've done up a little bit of a cheat sheet. So we will give you the PowerPoint as well. Alison will. This is a logistic regression cheat sheet. So for those of you who already understand regression itself, this can help you, because a linear regression R-squared, which tells you the variability of X and Y, or diet quality and depression, is the same as the Nagle-Kirk R-squared in logistic regression. The F statistic in linear regression, or the ANOVA box, and the p-value tells us whether the model is significant. In a logistic regression, it's the chi-square statistic and its p-value. In linear regression, the t statistic, or the coefficients box, and the p-value tell you what in the model is significant. In logistic regression, that is done with the Wald statistic and its p-value. In linear regression, the betas tell us how much Y increase for every unit increase in X. So remember we did that? So for a 1 unit change in diet quality, depressive symptoms go up or down by this much. In logistic regression, that's the exponential B or the odds ratio. So what we might do now is we might take a break for 5 or so minutes. What's the time? 10:30 exactly. Okay. Yeah, about 5 to 7 minutes. We'll have a break, go get a coffee or a tea, and we will come back and we will move into answering questions about using ANOVA, and I will show you JASP and mediation as well. Thanks, Alison. I forgot about that. Nice. All right. So another way, instead of doing logistic regression, another way to answer that research question about the clinical and non-clinical depressive symptoms is that we can actually split the whole SPSS file by the categories of depression and then run a normal hierarchical regression, just like we did last week. So if you want to do that, that is a completely fine thing to do, but just don't forget that once you've split a file in SPSS, it will remain split forever. So if you do that and then you go on and start doing other analyses and answering other research questions and forget that you've split the file, then all of your results will always be split by clinical and non-clinical depression. So just keep in mind. And it's really simple. You just go to split file. In the split file document, you compare the groups for the dichotomized depression scale, and that's it. And then you just run the hierarchical regression just like we did last week in the same blocks with the same things. And just keep in mind that your output will always be twofold. You'll have your regression on your participants with depressive symptoms, and then you'll have your regression on your participants without depressive symptoms. So there's kind of 2 ways of looking at the same thing, or 3 ways really, because we run the regression on the continuous data as well. So there's more than one way to skin a cat in analysis. Good. Okay, so let's move on to research question 2 then. So research question 2 is there a difference in depressive symptoms between the different plant-based diet groups? Now, when we did t-tests back in week 2, we looked at whether there was a difference between the vegan and vegetarian dietary groups and depressive symptoms. We found that there was no significant difference with a non-significant t-test. This time, we're going to have a look at all of the different plant-based groups and how they self-reported. So to do that, when we have more than 2 groups, we need to run an analysis of variance. So we're going to go into back into SPSS, and we will run an ANOVA. So here's our data set again. Just keeping in mind, if you split the file, make sure that you unsplit the file. We're going to go and keep in mind, we've done all our assumptions testing first. So the first step, if you are going to do an ANOVA, is participant characteristics and descriptives assumption testing. And there is an assumption inside the ANOVA that we'll have a look at as well. So making sure that we've got normality, making sure we've got linearity, independence, and those types of things before we go into our analysis. Then we want to analyze, compare means and proportions. We'll go to one-way ANOVA. In our dependent list, what's our outcome variable or our dependent variable? In this question, is there a difference in depressive symptoms between the plant-based dietary groups. What's our outcome variable? Depression, good. So we put the Center of Epidemiological Studies of Depression into the dependent list, and into the factor list, the variable that we're splitting by factors, we're going to put plant-based diet. Then we are going to go up to post hoc. So remember I was talking about post hoc analysis? Post hoc analysis is just analyses that are done after the fact, and this will tell us what in the model is significant. So we go to post hoc, we click Bonferroni. You can use the other ones. Bonferroni is just the one that I use. Each of them have their own separate reasons to be used. So if you're really interested in that, go and have a look. Andy Field, in his Statistics and SPSS textbook, explains all of these and what and how they're used and why. I've only ever used Bonferroni. Then we go into options. We want descriptive statistics. We want fixed and random effects. We want our homogeneity of variance test. That's our assumptions test. We also want our Welch test. Means plots, continue. And then the bootstrap button is there if you've got some problems with your assumptions testing that you found before. So linearity, normality, things like that. Then we click OK. Then I'm going to stop sharing and I will share my output screen. I'm still waiting for that to generate. Just waiting. It'll happen eventually. So SPSS is doing a lot of things in the background. So sometimes the output can take a little while. But on your front screen, it will tell you if it's running the analysis. Here we go. Okay, so the first thing that we get in our ANOVA output is a table of the descriptive statistics. So basically tells us in relation to the Center of Epidemiological Scales of Depression, keeping in mind that we are now using the continuous score, which ranges between 0 and 60 with higher scores equaling greater depressive symptoms. It tells us that we have 135 vegans. So big N, it tells us our sample size. Got 135 vegans in our data set, 29 semi-vegans, 77 vegetarians, 77 vegetarians and 8 semi-vegetarians, 28 lacto-vegetarians. They're people who avoid meat and eggs but include dairy. We've got 4 ovo-vegetarians that avoid all meat and dairy but still eat some eggs. Then we've got 22 low lacto ovo vegetarians that avoid all meat but include dairy and eggs. We've got 2 pescatarians that avoid meat except for fish. We've got 13 flexitarians that consume a mainly plant-based diet but occasionally include some meat and animal products. And so every time we do this and we have flexitarians, I always think that I should exclude the flexitarians from the data set, right? Because they're actually omnivores that eat mostly plants. So, but we haven't in this instance. So there we go. Now, one of the things that you need to keep in mind is that our semi-vegetarians, there's only 8 and there's only 2 pescatarians and 4 ovo-vegetarians. So that could have an impact on our results because there's so few in those categories. Now it tells us the next column tells us the average of depression symptoms for these groups. Now, who can tell me which group seems to have the highest average depression score out of all of those plant-based dietary groups? Matt, the pescatarians, they do, but this might be because there's only 2 of them. Who seems to have the lowest average depression score? The vegetarians, good, excellent, Rianne. So this gives us a little bit of an indication of what we're looking at, but this box is descriptive statistics. It doesn't tell us if those scores on depression are significant or not, or if there's a significant difference between the 2 groups. So we need to go and have a look at our inferential analysis. This box also can tell us confidence intervals, our minimum and maximum depression scores, things like that will give us a bit of an idea of what the data looks like, but not if it's significant. Then we have our tests for homogeneity of variance. So this is our test to make sure that those variances between all those groups are not too different. And being an assumption, we want this variable to be non-significant, so greater than 0.05. So we can see here, based on the average, our significance value is 0.130, which is greater than 0.05, which means we do not have a significant violation of our homogeneity of variance assumption. So we can move on. Assuming that our normality and linearity and our independence was all good, then we don't have any problems with assumptions for this test. Now our ANOVA box tells us whether the model is significant. So keeping in mind that this is starting to sound very repetitive. In regression, the ANOVA box tells us whether the model is significant. In logistic regression, the chi-square tells us whether the model is significant. Here, this ANOVA box tells us whether the model is significant. If this ANOVA is not significant, you do not go on to interpret post hoc analysis, which means you don't go on to see what in the model is significant. So who can tell me here, is our ANOVA significant? No. How come, Miranda? It's greater than 0.05. Correct. It is greater than 0.05. And this is a really good example of why this dichotomy between significant and non-significant is a load of bollocks, in my opinion. So there is not very much difference between a p-value of 0.49 or 0.049 and 0.051. And one is significant and one is not significant. It's a dichotomy that somewhere someone in science decided that that was the level that we would be acceptable or would be acceptable to be non-significant or significant. What's more important is our confidence intervals and whether or not our confidence intervals cross 0 or how far apart our confidence intervals are. So in this case, you are so correct. It looks like there is no significant difference between the depressive symptoms of the 5 groups. And that's where you'd stop. That's what you would report. But in all honesty, that 0.051 doesn't really mean that too much. And as a scientist, you would want to go on and explore that in a little bit more detail. But it also does, it is supported by the t-test of the vegans and vegetarians that there was no differences between those groups as well. So you want to look a little further into it if you've got a significance value like that. Now, if our ANOVA was significant, we would then move on to our post hoc tests, which tell us what in the model is significant. And they can be a little bit confusing because they compare the vegans with all the other plant groups. and whether there is and what the mean difference is, and whether or not it's significantly different. So it looks like here in this box that there is no significant difference between the vegans and any of the other plant groups, because all the significant values are greater than 0.05. Same goes for the semi-vegans. It doesn't look like there's any significant difference between the semi-vegans and the other plant-based dietary groups. And then sort of the same for vegetarians. It says here that there's not really any significant difference between the vegetarians and the other groups, the semi-vegetarians and the other groups. Where is the significance? The lactose, the OOs, I bet it's in pescatarians. Let's go have a look. Where are they? No, none of them in the model, in the post hoc analysis, are significant, which aligns with the fact that the model's not significant. If the ANOVA was significant, you would find significant values in those post hoc analysis between the groups. But the means plot's my favorite thing because it shows you this in a much easier to understand way. So the means and whether or not they were significant. Any questions about our ANOVAs? No? All right. So the last research question that we're interested in is remembering back to when we did our hierarchical regression last week, and we found that sleep quality, social connectedness, and sunlight exposure, when they were added to the model, diet quality no longer had a relationship with depression. That was strange. So the next post hoc analysis that you do is find out why that occurred. So I did a mediation on all three of them, but we'll just do one today. So social connection in particular, we went into this data collection knowing that there's always a relationship with social connection. Every single time we do a survey, social connection comes out as the highest predictor of depressive symptoms in relation to diet quality. So we kind of knew that this was going to could potentially happen. We've never lost the significance in diet quality before. That's only for this population. So something about vegetarians for life. And I have a feeling that it has something to do with religion, because all of the participants who have been vegetarian for their entire lives have been for religious or cultural reasons. So they might have more social connection because of their ties to religious community potentially. And this is all stuff that goes in the discussion, right? You start thinking, wow, why did that happen in this population? So let's go and have a look. We're going to see whether social connectedness mediates the relationship between diet quality and depressive symptoms. And what that means is, if there is a relationship between diet quality and depressive symptoms, is it because of the diet, or is it actually because of something else that impacts both diet and depression? So whether being socially connected increases your diet quality, but being socially connected also decreases your depressive symptoms. And that relationship between diet quality and depressive symptoms is completely or partially explained by how socially connected you are. So I want to introduce you to JASP. JASP is a free web-based software program that's almost identical to SPSS. So if you know the interface of SPSS and how the tabs work and how the data works, then you will know how to use JASP. The benefit of having JASP and putting your data into JASP is that your data is then no longer tied to SCU. So if you leave SCU and you're doing a project, you no longer will have the rights to SPSS, but you will always be able to access JASP. So if you have your data saved onto the computer in any form or any file, then you can download it into JASP. The only drawback of JASP is that manually entering data and variables is far more difficult than in SPSS. So you need to kind of have your data in Excel or in SPSS first and clean it in Excel or SPSS first before you put it into JASP. But that's the only kind of drawback. No, SPSS data can definitely be opened in JASP, and I'll be doing that today. Even if you don't have an SPSS operating system anymore and you have SPSS files on your computer, you can still open them in JASP. So that's a big thumbs up for the program as well. So if you lose your rights to SPSS when you leave SCU, then you will still, if you still have the SPS files on your computer, you can still open them in JASP. It can open, JASP can open any files from any software program. Matt bought SPSS to mitigate this issue. Oh, how expensive was that? The best thing about JASP, and the reason I'm staying on this screen is so that people can download it while I'm talking. $800, that's not too bad. When do you have to renew the license though? But do you have to pay every time you renew the license? I think you do. Anyway, when you renew the license, you can just switch over to JASP. Anyway, so it's amazing. Love it. And it's supported by Windows, Mac, and Linux, whereas SPSS is quite tricky on Mac and does some strange things sometimes. The other benefit of JASP is that, and I'll show you in a moment once everybody has had the chance to download it, it has the opportunity to do far more advanced statistical analyses than SPSS does, and the ones that we've already done can be done in a fraction of the time. So let's go and have a look at that, shall we? Is everybody finished with this slide? You can always come back to the slide, I guess, when Alison shares. So I'm going to step through getting your data into JASP from SPSS. I'll also show you how you can access Excel. Then we'll run a mediation analysis, and then I will explain the mediation output to you. So let's go. I'll stop sharing, and I'll see if this allows me to share my JASP. All right. So this is the front screen that you will see when you download JASP. You then go up to the three little lines at the top to put your data in. So you go to open, and you can even download data from Open Science Framework if you keep it in there. So Open Science Framework is a framework that we use to pre-register our the analyses that we're doing, so that we don't, so it keeps it transparent, so that we don't lie about our data in the publication. We're always registering before we collect data, what steps we're going to do, and what when we're going to close our data collection, things like that. But you can also upload your data into Open Science Framework and your cleaned data. And when you go to publish, you give the publisher or the journal a link to your Open Science Framework, so that if someone wanted to, they could access your data and run the tests. But you can also get data out of Open Science Framework and put it in JASP yourself. So go to computer, I browse, find where your data set is. There it is. And the same for Excel. Go browse, find an Excel. Any types of data sets that you want can be searched for. JASP, Stata, R, all of them you can use. We open, and the file is going to look very similar to the data tab in SPSS. Now, this is too big for me to demonstrate all the information, so I'm just going to go up to the ellipses again at the top. I'm going to go to Preferences. I'm going to go to Interface, and I'm going to zoom out to 50%. And that will bring the screen the information on the screen down a little bit. So everything's smaller. Right. So here we have it. We've got our 319 participants. We've got each of the variables or the survey questions that they answered, just like we had in SPSS, identical. Interestingly, the value variables or the categorical variables transport over the category and its label. So married and whatever married is on that, you can double click on the variable and change it. Why did it do that? Can you still see JASP, or has it flicked over to SPSS? I should cancel SPSS. Oh, I know why. Okay. So when you click on it and you want to change it, it might take you back to the original data set. So here we go. We've got our data set. Just to show you a little bit, what have we got here? Still on JASP. Oh, that's good. So here's our descriptive statistics. If we open that, a little box comes up on the side. So it consistently and continuously upgrades your data as you're running it. 50 might be a bit small. I'll just put it up to 60. That's better. All right. So we could say run our descriptive statistics for our categorical variables. So gender, marital status, our vegan and vegetarian dietary groups. And as you can see, as I'm adding variables, it's automatically generating the descriptive statistics for those variables. Right now, it's doing quantitative descriptives on the categorical data, which is not super useful. So let's do our continuous variables. So age, and there it pops in the mean, the standard deviation of age. I put BMI in, it adds it automatically. You can split the variables. You can then add a plot. We could do like a box plot so that we can see if there's any outliers. We can do a correlation plot, which will give us a scatter plot immediately. So there are assumptions checking. You can do your QQ plots, which is another assumptions test. And then you can choose your statistics. If you wanted more than mean and standard deviation, you could add your median. You could do your mode. You could do all your other variables there. So from a publication point of view or from a thesis point of view, is there a problem using JASP versus SPSS? No, they're exactly the same. It's just a software program that you use to generate your data. So there is no problems at all. Cool. You can also do your Shapiro-Wilks assumptions test. So they're your descriptive statistics, and they can run them as you're going. So it's really, really cool. You've got your normality plots there, everything. You'll also see that the JASP is already in APA 7 format. So you can just click on the arrow box, copy and paste directly into a Word document. So it's super convenient compared to SPSS, which you have to like go in and do all that. So that's your descriptive statistics. Again, you could do your categorical variables if you clicked on frequency tables and you got rid of your statistics, your quantitative stats that you don't need. Click on your categorical variables and it creates frequency tables exactly like what we did in SPSS, telling us how many participants were in each category and what percentage there are. So immediately your descriptive statistics are done. The same goes for your tests. So we did a t-test. We could do a independent samples t-test. We put the two variables in. What was the t-test? We did vegan and vegetarian as the group, and we did depression as the variable. we can click that we want a Cohen's d effect size. We can click assumption of normality, homogeneity of variance. And as we do that, everything comes up. We can get our descriptive statistics. We can do all of that. So, and that tells us a t value. It tells us that it's not significant, which is what we found in week 2 when we did that. It tells us our normality. There's problems with normality there. And then if our t-test was significant, then our descriptive statistics would tell us which group had the higher depressive symptoms than the other. So just JASP is like really super convenient and easy to use for both inferential and descriptive statistics. Now, the one thing that it is super useful for is mediation and moderation. Matt says this looks more user-friendly. It is in some ways, and it isn't in other ways. Like, you have less control over manipulating your variables, so you can't take, like, changing the actual data when it's in there is more difficult. But yeah, once you've got your data clean and ready, it is easier program for many things. All right, let's look at mediation. So we want to know whether or not this weird anomaly that we found in our regression is because social connectedness has completely taken away the relationship between diet quality and depressive symptoms. So to do that, we need to go up here to SEM, that means structural equation modeling. Click on it, and there's your mediation analysis. Now, your mediation analysis will pop up. Our predictor variable. Now, the important thing with, before you do a mediation, there's 3 things that you need to have. Your predictor and your outcome variable, so diet quality and depression, need to have a significant relationship. Your predictor and your mediator need to have a significant relationship, so diet quality and social connectedness. And your mediator and your outcome variable need to have a significant relationship, so social connectedness and depression. So before you would do this, those variables should be significant. Considering this is an add-on or a post hoc analysis to a regression analysis, that assumption has already been met. You can't do a regression with non-significant variables. So those assumptions are kind of already intact. But if you wanted to just run a mediation analysis on data that you haven't done a regression on, you would need to ensure that those relationships existed before you tried to do a mediation. So our predictor variable is diet quality. Our mediator is social connectedness. And our outcome variable is the CESD depression scale. Now, in this background confounders box, you can put your covariates in if you want. At this stage, I think that adding covariates to mediation will just muddy the waters and make it less clear. So we wouldn't. And as you can see here, it's actually running my mediation analysis as I go. Matt, what did SEM stand for? Structural equation modeling. And I'm not going to go into the intricacies of that because that is a whole other workshop. Okay. So we've got our total indirect effects, we've got our residual covariances, and we've got our bootstrap option. So you can bootstrap inside of JASP as well as SPSS. That is a thing. I don't think we need any other information there. Plots, and this is the most important part about mediation analysis, because when you report mediation, you report it in a figure that looks like this. And SPSS will not create this for you. It's taking a little bit. So while it thinks, I will explain the mediation itself. So the direct effect of the mediation, the first box, tells us the relationship between diet quality and depressive symptoms without the mediator involved. And you can see this from this, the front of the box tells us diet quality and arrow to depressive symptoms. So this is the relationship between those two variables without the mediator in them. It's significant at p.006 because remember, we don't have our confounding variables in there now. All we have is diet quality and depression, and it was significant in our regression. So that's good. Our Z value is minus 2.77. Now that's important because I'll show you in a second. Our indirect effect is the relationship between diet quality and depressive symptoms through social connectedness. This is also significant. The indirect effect is significant at less than 0.001 with a Z value of 0.435. Then our total effects is diet quality and depressive symptoms after the mediator has been included. And this is also significant at negative 5.11. So what does that all mean? I'll show you in a second. No worries, Matt. So when we report our mediation, we report it in a table, and we also have to report this figure. SPSS does not do this figure for you. Traditionally, we have always created this figure in Word, and it's annoying because you have to do the arrows and the boxes and the values, and it's really hard and tricky. So when JASP came out, and when I first found out about JASP and it does the figure for you, it was like the best thing that has ever happened. So social connectedness is at the top there. It's the mediator, diet quality and depression. So diet quality, the first line at the bottom is the relationship between diet quality and depression. The line here, or the line between diet quality and social connectedness, and then there's a line between social connectedness and CESD. So to explain that in a little bit more detail, I'll go back to the PowerPoint. So this is how to explain the mediation model. If there is no significant mediation, then social connectedness does not explain the effect of diet quality on depressive symptoms. And the total effect would be less than 0.05. If there is a complete mediation, then the effect of diet quality on depressive symptoms is entirely explained by social connectedness, and your total effect would be non-significant, so greater than 0.05. What that means is that when you add social connectedness to the model, the relationship between diet quality and depressive symptoms becomes non-significant. That's what that total effect of greater than 0.05 is. But what we actually found was that there wasn't a complete mediation because that total effect was less than 0.05. But in the case of a partial mediation, there is a direct as well as an indirect effect on diet quality on depressive symptoms through social connectedness. So if the total effect is less than 0.05 and the Z of total effect is greater than the Z value for the indirect effect, that means there has been a partial mediation of diet quality and depressive symptoms through social connectedness. So what that means is that social connectedness doesn't fully explain the relationship between diet quality and depressive symptoms. It partially explains it. So if you're interpreting this in a discussion, you would say something along the lines of the way that we eat or our social eating habits does have some form of a impact on diet quality and depressive symptoms, but doesn't remove the whole of the importance of the actual diet itself. If there was a complete mediation, you would interpret this in a discussion as, although there looks like there is a relationship between diet quality and depressive symptoms, that is completely explained by social connection, which means that diet quality or social connectedness, or how socially connected we are, impacts diet quality. It impacts depressive symptoms. And it looks as though there is a relationship between diet quality and depressive symptoms, but that is actually because of how socially connected you are. So those who are more socially connected will have a higher diet quality and higher depressive symptoms, and it's like a third variable problem. So it removes the relationship between diet quality and depressive symptoms. But what we actually found was a partial mediation. So there is some form of a relationship or a prediction of the diet itself in depression, but the way that we are socially connected greatly impacts that relationship. How did everybody go? Any questions about that? Mediation is quite a tricky one to interpret in your mind. And probably if you're going to do mediation in your analyses, it's worth having a whole workshop on mediation, or fully getting into learning the interpretation of mediation. My brain hurts too. It's okay. Yes, there is a lot to think about with mediation, and that was just scratching the surface. To really fully understand mediation, you need a 2-hour workshop just on mediation, basically. And before that, you need to understand hierarchical regression completely before you can interpret and understand mediation as well. It is exactly that, and you can do mediation inside regression. You can build the blocks of the model so that it represents a mediation map. So you're right onto it. That's very intuitive. You would always do hierarchical regression before you did a mediation. Mediation usually happens if you find something in the model where you're like, whoa, why is that happening? Why has that removed that relationship? Although some people do build research questions around mediation from things they've found in the literature, if you know what I mean. So if you found the literature on diet quality and depressive symptoms, and then you found heaps of literature on social connectedness and depressive symptoms, and you're like, I wonder if social connection actually removes the diet quality relationship, then you could build a research question from the literature rather than from your own regression. Any more questions? These are really good. No worries, Rianne.
Megan and Alison, I'd just like to thank you both for putting these sessions together. I can't say that I've followed all of the detail, but I've definitely benefited from some of the big picture stuff, and I will be accessing the videos when the time comes to analyze my data. So just thanks very much.
No worries. And Daniel, feel free to reach out anytime if you need any help or any advice on analysis.
Appreciate that. Thanks, Megan. And
no worries.
Might do so.
Thank you. Any last questions as we're wrapping up? Now's your chance. I think everyone's brain hurts.
Like I said, that final advanced statistics workshop is advanced, but it's like
Absolutely.
There's other stuff out there that's like even more crazy advanced, but that's scratching the surface of the more advanced techniques that are most likely to be used in like PhD or master's things or honors.
Yes. Yes. Well, that's excellent. Thank you so much, everyone. And thank you so much to Megan for giving our students some high quality skills training in statistics and SPSS. So we look forward to working with you again, Megan.
No worries. Matt just said, so the textbook on SPSS is still useful for JASP. It is, Matt, it is. So all of the theoretical stuff in Andy Field's SPSS textbooks are super useful. I will send Alison a free online JASP textbook. That's also really useful to have handy.
Excellent resources. All right, I might just stop the recording there.